everyone. Today we are going to discuss one question related chapter 4 in our chemistry. Okay, iodine pentafluoride IF5 as intermediate compound is widely used in the production of alkyl iodides in the synthesis of fluoroorganic compounds. These are used to produce water and oil repellent emulsions for the treatment of textile and letters and for fire extinguished foam. Okay, let's look to the first question. Draw the level structure of IF5 and state the unusual feature of the molecule. Okay, before we drawing the level structure, we need to determine the total valence electron of them. Okay, and we also need to determine the central atom and the terminal atom. It's very obvious iodine is the central atom and the terminal atom is fluorine. Okay, for one iodine atom, they got seven valence electron, and for one fluorine, they also got seven valence electron lah. But in the molecule, they got five fluorine atom. So with 7 times 5, which is 35 valence electron. And iodine got 7 valence electrons, so we total it up and the total valence electron is 42. After we total it up, we need to draw the level structure lah. Okay, after that we need to determine how many bonds form between them. Okay, for one bond that form 2 valence electron, and as the picture we can see they got 5 bonds formed, so there are 10 valence electron produced lah. So with 42 minus 10 valence electron, and the answer is 32 valence electron. Hence, we need to use the 32 valence electron to fill it into the level structure. And for the fluorine, we need to let them to achieve octet lah. So octet means 8 valence electron. Okay. For the bond, we already know that got 2 valence electrons. So for the fluorine, we need to fill up more 6 valence electron. So the total valence electron for one fluorine is 8 lah. But when we have filled it out, we have left 2 valence electron at there. So we add the 2 valence electron in our iodine atom. Hence, the answer is like that lah. And the unusual feature of the molecule is expanded octet. Okay, let's move to the another question and state the hybridization of the central atom in IF5. And the answer is sp3d2. Okay, the third question is describe the hybridization process of central atom in IF5 using orbital diagram. Okay, we know that the central atom is iodine, right? Okay, so the ground state electron configuration of I is this one. Okay, in 5s we got 2 valence electron, and 5p got 5 valence electron over there, so we left one at there lah, because there's 5. Okay, promoting two 5p electrons into a 5d orbital result in the following excited state, which is this one, the excited state. We need to move 2 valence electron to the 5d orbitals from 5p orbitals. Okay, mixing 3 5s, 3 5b, 5p, and 2 5d orbitals, it will generate 6 sp3d2 hybrid orbitals. And the hybrid state is this one, which is sp3d2, and they got 1 2 3 4 5 6 electron at there. Okay, let's move to the fourth question. Okay, draw and label the overlapping orbitals. Okay, first thing first, we need when we are drawing, right, we need to label it out. Okay, we need to label whether the F at there and the iodine. Okay, for the F, we know that it's dumbbell, so we need to draw it like a dumbbell shape lah. After we draw, we need to write the sigma bond, and we also need to write the valence electron at there. So next. Okay, for the fifth question is state the polarity of IF5 molecule and explain. Okay, polarity of IF5 is polar. This is because all the IF bonds are polar bond, and bond dipoles do not cancel each other, and the net dipole moment is non-zero. Okay, let's move to the fifth question. Predict the bond angle. Then the answer is less than 90 degree. Okay, because the lone pair on the central iodine atom, they will exert more stronger repulsion on the 5 IF bond. This repulsion will forces the fluorine atoms closer together and destroying the ideal octahedral geometry and slightly reducing the bond angle from 90 degree. Okay, let's move to the last question. Okay, from table 1, you guys can see the gas HBr, NH3, and CH4, and the boiling point from them. Lah. Okay, explain the differences in boiling point of three molecules. Okay, when we are answering this question, we need to determine the bond formed between the molecules, each of them. Okay, from NH3, we know they form hydrogen bond. Why? Because hydrogen bond they contains H, right, which is hydrogen atom. Hydrogen atom will form a bond between fluorine, oxygen, and nitrogen. So we can see nitrogen and oxygen will form a hydrogen bond between them. Okay, so we can determine NH3 is a polar molecule and form intermolecular hydrogen bond. Okay, and HBr is a polar molecule that forms stronger intermolecular van der Waals, which is dipole-dipole forces. Meanwhile, CH4 is a non-polar molecule and form weak intermolecular London forces. Hence, we can conclude that hydrogen bond is stronger intermolecular forces than van der Waals. Therefore, NH3 has highest boiling point.